Okay. Number 1. State all excluded values. Where do I find excluded values? The denominators. Now, I cannot get excluded values from denominators if they have not been factored. So the first thing I need to do is I need to factor this guy, which means I need to technically snowflake. To save a little bit of time in here in class, I'm going to go ahead and do the snowflake for you. It becomes plus 4 and minus 2. Yes? Good answer. All right, so if x plus 4 and x minus 2 are in the denominator there, what are my excluded values from there? Negative 4 and positive 2. This denominator, when I factor it, I get x and x minus 3. What are my excluded values from there? And yes, I said excluded values. 0 from here and 3 from there. Now, there is one part of this question that is a trick. Yes, it is a trick. Yes, it is intentional. And it has to do with this guy right here. What is that? A division sign. If that was a plus sign, a minus sign, or a multiplication sign, I would be done right now. But because it's a division sign, I not only have to look here for excluded values, but at some point, this is going to be a denominator, and therefore excluded values need to be found from here also. That only happens in division, because division is the only circumstance where you flip a fraction. So if I factor this top, it factors into x plus 3 and x minus 3. That gives me a value of, what, negative 3 and positive 3, which is already on my list. Now my list is complete. So again, if this was addition, subtraction, multiplication, I would only look at the two denominators. Because it's division, I have to look at this numerator too, because a division problem forces you to flip at some point. Questions about that one? Yes? No? Okay. Number 2, identify the least common denominator. You notice it's not a add, subtract, multiply, or divide sign. It's just a comma. Because it's just two fractions. We don't want you to add, subtract, multiply, or divide. We just want you to talk about denominators. So do I care that the numerator is 3x squared plus 7x? No. It could be a smiley face. I don't care. Do I care that this numerator is 45x squared? No. All I'm concerned about is these denominators, and they must be factored. So that leaves me with x minus 3. Yeah? 4x, x minus 3 there. Okay. And then here, let's see, I think I can take out a 5, and that leaves me with x squared plus 9x minus 36. And that can actually factor into x plus 12, x minus 3. So I'm not looking at that denominator or that one. They're all equivalent. I'm looking at the most factored form. Now, it cracked me up because there were a lot of groups that did this. They wrote their answer as 4x, x minus 3, 5x plus 12, x minus 3. They just literally wrote both denominators together. And I sit there and I'm like, okay, well, why can't you multiply the 4 and the 5? Or look at the 4 and 5, I should say, and get the common denominator, which in this case it is 20. And then you have an x also. But if you have an x minus 3 in this denominator and an x minus 3 in that one, you only have to write it once. Right? That's my LCD. This is a common denominator, but it's not the least common denominator. So I should be able to see the 4 is in here because 20 is divisible by 4. I see the x not in parentheses. I see x minus 3. I see 5 because 20 is divisible by 5 also. I see the x plus 12. I see the x minus 3. I should be able to see all components of all denominators in my LCD. Questions there? Okay. All right, Add or subtract the given expressions. These are the two hardest questions on the test, I think. For a lot of people they are. Because they want to solve them like the questions on the back. With the equal sign. Okay, now with adding and subtracting I must do what? I must find an LCD. Multiplying, dividing, no need for an LCD. Adding and subtracting have to have an LCD. So, in this first fraction, can x plus 2 be factored? No, so I throw it in parentheses. Yeah? Can x squared minus 5x minus 14 be factored? Yes, and you can snowflake that. It becomes x minus 7, x plus 2. And I'm not going to look anymore at that form of the denominator. I'm only going to look at the factored form. So what is my LCD? X minus 7 and x plus 2. Okay? Now, unlike the problems on the back, with the equal signs, I'm trying to get rid of denominators. I'm not trying to get rid of denominators when I'm simply adding and subtracting. I'm just trying to write them with a common denominator. And people like to skip this step and try and do it in their heads. And I'm telling you, take the extra 30 seconds to do this step because it will help keep things straight and make you less likely to get it wrong. Okay? I have two fractions I'm trying to add. I can't add them unless they have a common denominator. So I'm going to write it as two fractions with a common denominator. And that common denominator I'm going to use is the least common denominator. So far, so good? Now, some people just said, oh, okay, now I'm just going to bring down the 2x and the 17x minus 2 and go from there. Problem. What's the problem there? If I change the way denominators look, then the numerators are going to have to change too. You can't just keep the numerator the same. So let's see. If I have x plus 2 on the bottom, how is that different from this denominator? It's missing the x minus 7, isn't it? So I would need to multiply this by x minus 7 in order to get it to match. Yes? So guess what? I have to multiply the top by x minus 7 also. In other words, it's no longer just 2x, it's 2x, x minus 7. Now, I want to talk to you about something. You can check to see if you did this correct. Because if, and I say that very strongly, if you were to cancel out the x minus 7 and the x plus 7, I'm sorry, the x minus 7 and the x minus 7, you should be left with what the original fraction was. Are you? Yeah. 2x over x plus 2? Mm-hmm. Yeah. You are technically unreducing this fraction in order to get a common denominator. Now, do you want to cancel out the x minus 7s? No, because that takes you back to here. Why do you want to go backwards? Right? So we want to keep it that way. The next fraction. How is this denominator different than this one? It's not. So what does that mean about the numerator? It stays the same. So let's go from here. I have two fractions. They now have the same denominator. When I add them, they will also have that common denominator. And this is when I got fancy and got out my little sticky notes. And you can do this on the side, but I think understanding-wise, it's a little bit easier to just do this. I got to deal with those numerators. So what have I got? I have 2x squared minus 14x plus, and I'm kind of going to distribute that plus sign because if it was a minus sign, it would make a difference. But I have plus 17x and minus 2. Are you okay with that? Yes. Now, I could write that on top right now, but then I'd still have to continue simplifying some stuff. So I'm going to simplify this further and call this 2x squared, what? Plus 3x minus 2. And I could write this on top because it's more simple. And some people chose to. By the way, do I need to state the excluded values? No, because excluded values really have no purpose until you get to the equal sign ones. Okay? But am I done? Why am I not done? I can factor that. Yeah? I think it's 4 and negative 1. So let's see, this becomes x plus 2, and then 2x minus 1 over x plus 7, x plus 2, and I've got some canceling. So my final answer is 2x minus 1 over x plus 7. Yes?
When did it become x plus 7?
When I stopped reading it correctly. It's not an x plus 7, it's an x minus 7. Thank you. Ah. Oh, come on. That's an x minus 7 and an x minus 7. I was so intent on making it an x plus 2 because last period I accidentally called it x minus 2 and things weren't canceling. And I was like, what did I do? Thank you. I love whiteout on colored paper. That's so fun. Said nobody ever. Okay. You ready for number 4? Now, number 4 is kind of interesting because you could treat the x and the 5 as 2 separate fractions, or, and I think this is easier, just treat it as 1 fraction. It's easier. Okay? All right, so that's over 1. This is over x minus 3, which can't be factored, so I'm putting parentheses around it. I'm going to go ahead and draw a line here just so I don't get confused with the work from that problem. What is my LCD going to be? X minus 3. That's pretty easy. So let's see. I have a fraction minus a fraction, and I want both of them to be over x minus 3. Okay? So I'm going to write the numerators currently as they are, but I know that I have to multiply them by something. How do I get this denominator to match that? What do I have to do? Multiply by x minus 3, right? Now watch very carefully. If I multiply this top by x minus 3, is that correct, the way I have that written? I hear no, but that's a questioning no. Yes or no?
No.
Why not? The way I have it written, it's only the 5 that's being multiplied by the x minus 3. Do you see that? I have to distribute, which means this technically has to be in parentheses too. Okay? And again, I should be able to just kind of cover up what could cancel and see the original fraction there, because I'm unreducing. Do I need to do anything for my other fraction?
No.
Why not? Already got it. Okay? So I know that my answer, or the result here, is going to be over x minus 3. Yes? And I'm going to get out my little cheat sheet here. I have x squared minus 3x minus 5x plus 15.
Yes.
And then do you see that this is a minus sign right here?
Mm-hmm.
This minus sign has to be distributed here. So I have minus 3 plus 8x. Yeah? So I have x squared. Negative 3x and negative 5x is negative 8x and positive 8x. All that cancels. So I have plus 12. Can that factor? They have nothing in common. I don't think I can factor that. So I just have x squared plus 12. Done. Questions there? Any questions about 3 and 4? Tomorrow I can't answer any questions for you, so ask away. Nothing? All right. Now to the 2 easiest problems on the whole test. Yes? Please tell me you're not going to miss these ones. All right. I have fraction times fraction. No need for LCD here. Do I need to state excluded values? No need to state excluded values. I have fraction times fraction. I just need to factor, and then I can start canceling. Excuse me. All right. This dry air is driving me nuts. All right, x squared minus 6x plus 9 will factor into x minus 3, x minus 3. You can go ahead and do snowflake to see that that's true. Over here I can take out an x and I'm left with x minus 5. Up here I can take out a 2x squared and I'm left with x minus 5. And down here I get x minus 3, x plus 2. Everyone okay with that? With the multiplication problems, I just make one giant fraction and I start canceling. What cancels? X minus 3, x minus 5. What else? X cancels with one of those 2 from the x squared. So I have 2x, x minus 3 left on top, right? Both of those are left. And then on the bottom I have x plus 2. All right, next one. I'm going to change this to multiplication, and I can as long as I do what? This is division. I need to flip that fraction. So that's going to be 4 on top and x minus 4, which cannot be factored, so I'm going to put it in parentheses on the bottom. The other fraction stays the way it is. X squared minus 14x plus 40 becomes x minus 10, x minus 4. And 8x minus 80, I can take out an 8, and I have x minus 10. Since it's multiplication, now I can make it one giant fraction, and what cancels? X minus 4s, x minus 10s. I have 4 over 8, which reduces to 1/2. Those 2 should be the easiest and quickest problems on the whole test. Any questions there? Yes.
So for number 5,
Uh-huh.
when you cancel it out, so it was the x, there's 3x minus 5, right? I was going to all cancel it out.
It wasn't. This was x minus 5 and this was x minus 5. This was x minus 3 and this was x minus 3.
Oh, yeah, okay.
Okay? All right, turning the page over. By the way, if you know what you're doing, these 2 problems do not take long. You should be able to finish both of those in 5 minutes, no problem. Right? 5 minutes should be ample. These 2, 5 minutes should be ample. So you're talking 10 minutes there. Let's say you take 10 minutes on these ones. You're still only looking at half the period for the front side. Right? That's 30 minutes. That's giving a lot of time to do those. That leaves you another 25 minutes to do 4 problems. If it takes you longer than 25 minutes to do 4 problems, you don't know what you're doing. Right? That's a ridiculous amount of time, isn't it? I don't know why we should move it into 2 days, really. Okay. Solve using a rational equation. A table might be helpful. I'm going to change this. A table will be helpful. Please make a table. Okay? We have 2 people. We have Derek and we have Catherine. Do you know who Catherine is? Me. Do you know who Derek is? Mr. Morrison. We're always in competition. Always. Mr. Morrison next door. Okay. So let's see. D and K. Here's my table. You ready? By the way, my table has 6 spots to fill in. 4 need to be filled in with information from here. Then I can go from there. All right? So Derek can grade the stack of tests in 6 hours, which means he can complete 1 full job in 6 hours. Working together, Derek and Catherine can grade the stack of tests in 4 hours. This second column is always the time working together. Always, 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 always. Find out how long it would take Catherine to do it alone. So I can complete 1 job in some amount of hours. We don't know how many hours. Can you set up a table like that? That's the hardest part. What's 1/6 times 4? 4/6. What's 1 over x times 4? 4 over x. Set up my equation by doing 4 over 6 plus 4 over x equals what? 1 full job. What's my LCD? 6x. So what do? Multiply by 6x over 1, 6x over 1, 6x over 1. What cancels here? So I'm left with 4x. What cancels here?
X.
Plus 24 equals, nothing cancels there, so 6x. Subtract 2x. 24 equals 2x. What does x equal? 12 what? Sorry, my brain was 1 step ahead. I was thinking of the answer. You're subtracting 4 and you get 2x. Now does it make sense?
Yes.
Sorry. My brain was already at the answer. Yes.
Wait, the 6x1, I got lost just right
Right here?
there.
Okay, what's 1 times 6x over 1? 6x over 1 is just 6x, right? And 6x times 1 is 6x. Yeah? Were you okay with the 4x and the 24? 4 over 6 times 6x. You make one giant fraction. Your 6's cancel. You're left with 4 and x. That's where the 4x comes from. Right here, that one multiplying by the LCD, the x's cancel, so you're left with 4 and 6. 4 times 6 is 24. Okay, so then you just move your 4x over, divide by 2, and you get your answer. Okay, not too bad? Okay, I'm going to have to work on that because there's no way that it would take me 12 hours to do something that Mr. Morrison could do in 6. No way. Okay, all right, last 3 problemos. Solve each equation. Remember to use the excluded values to check for extraneous solutions. Does it say I need to list what the excluded values are?
No.
It does not say I need to list them. Is it helpful to list them? Yes, but it is not a required part of this. I do, however, need to know what they are in order to check my answers for extraneous answers. Okay? Now, I did have one group, I can't remember what period it was, but they looked here and they're like, okay, 2x plus 7, that gives you negative 7 halves, right? And x minus 1, that gives you positive 1. And they said this. Extraneous. That word, right? There's a problem with that. Extraneous means it's a solution that gives you a statement that could work out. However, it gives you that impossible fraction, right? So these are not solutions. They're not extraneous solutions. They're numbers that need to be excluded if they came up as a solution. So please don't call them extraneous. Call them excluded, or even faster, EV for excluded values. Okay. So just keep in the back of your mind, you need to keep a watch for -7/2 and +1 in this problem. Okay? Do I need an LCD for this one?
Yes.
Usually the answer is yes. However, because this one is in the fraction equals fraction form, I don't need an LCD. What can I do for fraction equals fraction? Cross multiply. And I don't need to worry about an LCD. So let's see. Can I use the LCD method? Absolutely. But I don't have to in this case. So let's see. X plus 1 times x minus 1 equals 2x plus 7 and x minus 3. And by the way, just to make sure that we're all clear, it doesn't matter if you do the x plus 1, x minus 1 on this side and the 2x plus 7, 1 on this side, or if you do these in the reverse order. It doesn't matter. Okay? So, I'm going to multiply x squared minus x plus x minus 1. That becomes x squared minus 1. You follow? Over here I have 2x squared minus 6x plus 7x minus 21, which becomes 2x squared plus x minus 21. Now, with all three of these solving problems, you're going to end up with an x squared. That's not true. With many of the solving problems, you're going to end up with an x squared. And your rule when you have the x squared is get everything to the same side, so it equals 0, and then factor to get your answers. So I need to move everything to the same side. I want my a value to remain positive for factoring. So I'm going to move the x squared because I'm still going to end up with a positive a value. Do you see that? Good answer. I'm also going to go ahead and add 1 in this same step, if that's okay with you. So I have 0 equals x squared plus x minus 20. Questions there? Yes? No? When you do the snowflake here, you will get x plus 5 and x minus 4. Giving me an answer of x equals -5 and x equals +4. Are either of those my excluded values? No. So they are both valid answers. Questions about that problem? Yes?
You did the 1 and the -x squared, you just knew that would make it 0, so that's why you used those numbers?
Yes. Technically, long ago in Algebra 1, you would have learned to do this 2 steps. You would have done, I'm going to subtract x squared, and then that gives you x squared. You would have -1 equals x squared plus x minus 21, and then you would add the 1 in another step. I just did them both in the same step. If it's confusing to you, go ahead and do it in 2 separate steps, no big deal. Okay? All right, you ready for number 9? I think I'm actually going to skip number 9 right now. I'm going to do number 10 next, because number 10 I think is a little bit easier than number 9. They're not too bad, though. All right, I need to find an LCD because I do not have fraction equals fraction, so I cannot cross multiply. So if I factor this denominator, that gives me x times x plus 5. This is an x, this is an x plus 5. What is my LCD? X plus 5. Because I have to include the x that's not in parentheses, which shows up here and here, as well as the parentheses. Questions there? Okay, again, this is the step people don't want to write, but I'm telling you, take the 30 extra seconds to write it, because it helps. I'm going to write all of the original fractions with an awkward space after them. So I'm leaving an awkward space here. Minus 2 over x, leave yourself an awkward space, equals 3 over x plus 5, and there's plenty of space there. What do I fill in the awkward space with? the LCD over 1. LCD over 1, LCD over 1. Why am I doing that? Because when I make these into one giant fraction, denominators are going to cancel. So when my x plus 5 cancels, x and x cancel, I'm left with 5 over 1, which is just 5. Do you see that? In here, what's going to cancel? The x. So I have minus 2 parentheses x plus 5. And then over here, what's going to cancel? X plus 5, so I have 3x. Is that a difficult equation to solve? Shouldn't be. Before I go on and solve this, though, I didn't talk about what my excluded values are. What are my excluded values? 0 and negative 5, right? 0 from the x, or from the x right there, and 5 from here. All right, so let's see. I have 5 minus 2x minus 10 equals 3x. What's 5 minus 10? So I have negative 5 minus 2x equals 3x. Do I have an x squared? I don't, do I? So I just want to get x's together so I can get them by themselves. So I'm going to add 2x. So negative 5 equals 5x. Divide by 5, and what does x equal? Negative 1. Is that any of my excluded values?
No.
Nope. So my answer is good. I think a lot of people tend to overthink these problems and make them a lot more difficult in their head than there actually are. But I'm telling you, if you take the time to write out this extra step, rather than trying to squish in your work in here, it helps keep your brain clear when your writing is clear and when your work is neat. Okay? Yes? How did the 5 become negative? Because I was adding positive 5 and negative 10. A lot of people kept that 5 positive there. Any other questions on that one? All right, we ready for the big finale? Here we go. All right, again, I need to find an LCD. X minus 5 cannot be factored. X minus 6 cannot be factored. Amazingly enough, x squared minus 11x plus 30 factors into, guess what? X minus 5, x minus 6. Is that any surprise? There should be familiarity. In other words, this one should factor and have at least an x minus 5 or an x minus 6, usually, so that it can correlate to those other ones. Okay, so what's my LCD? X minus 5, x minus 6. What are my excluded values? Positive 5 and positive 6. All right, so now I'm going to do that step right here where I'm going to write the equation with those awkward spaces that I can fill in with the LCD over 1. So x minus 3 over x minus 5. I'm going to throw both the numerator and the denominator in parentheses. Leave an awkward space, plus 1 over x minus 5, x minus 6. Leave an awkward space, equals 1 over x minus 6. I'm going to fill in that space with the LCD over 1. X minus 5, x minus 6 over 1, and x minus 5, x minus 6, running out of room, over 1. Any questions with where I'm at so far? Okay, so now I have 3 separate situations where I make one giant fraction and I start canceling. What can I cancel here? X minus 5, that leaves me with x minus 3 and x minus 6. I'll FOIL that in my next step. Next, I have a plus sign. What cancels here? X minus 5 and x minus 6. So a lot of people just changed that plus sign to an equal sign and moved on. But when it cancels out, it's not canceling out to 0. What is x minus 5 over x minus 5? Or x minus 6 over x minus 6? It cancels out to 1. So it still exists there. And a lot of people missed that one. And if you missed that one, you got to a place where you couldn't factor to get answers. And that was a problem. Over here, what cancels? The x minus 6. So I have 1 times x minus 5, which I can just call x minus 5. All right, can I keep going? I have x squared minus 6x minus 3x plus 18 plus 1 equals x minus 5. So let's see, I have x squared minus 9x plus 19 equals x minus 5. So I have an x squared. What do I need to do? Move everything to the same side as the x squared so I can factor. So I'm going to subtract x to move that guy. And what am I going to do with the 5? Add the 5. That gives me x squared minus 10x plus 24 equals 0. And when you snowflake, this becomes x minus 6, x minus 4 equals 0. So I get x equals 6 and x equals 4. Can I box both my answers?
No.
Why not?
Because
6 was excluded. So I just crossed that out and only boxed 4. By the way, what if both my answers crossed out? It would be no solution. Okay? I guarantee that on one of these problems somewhere there's going to be at least one time where you come across an excluded value. At least one time. Okay? Happy study.